In this video, I'm going to answer some questions that came in through the Desmos lessons, as well as through Google Classroom, that I thought it would be best to maybe make a video to answer these questions. I'm going to start the video with some questions that pertain to Math B Essentials. And then after I answer those questions, I'll move into some questions that pertain to Math B Honors. So feel free to fast forward the video or stop the video if I start to answer questions that don't pertain to your math course. The first few questions are going to be for Math B Essentials, but I guess it could also apply to Math B Honors, which is this how all the lessons are going to be? Yeah, for the foreseeable future, we're probably going to go with the same format for Math B Honors and for Math B Essentials. So whatever you saw this week is probably what's going to happen in the coming weeks, but I will be adjusting it um, as we keep moving forward. But I would anticipate that that's the way it will be. Next question came in from Math B Essentials. For the graphs, do we have to do an equation with the numbers in the question and then get the answer, input it on the graph, and the answer is yes? So I'll just kind of come up with a sample problem to maybe illustrate this. Let's say that we had a slope of 2 and we had a point of negative 3, 4. Our job in that lesson was to find b and to put all of this back together in an equation that would be y equals 2x plus whatever b was. Could be minus. And so what we did was we picked our point and we plugged it in, which would be 4 equals 2 times negative 3 plus b. 4 equals negative 6 plus b. We added 6 to both sides and we got 10. B equals 10. And then we took 10 and we put it back up here. And the reason that we had the graphs in the Desmos lesson was it sort of offered a nice visual, which we don't always have when we do this. And I'm going to graph this. So the point was negative 3, 4. And the equation was y equals 2x plus 10. And so we can see that we have a line, it passes through the point, and it actually does have a rise of up to right 1 if we just pick a point on the graph. Or we could even use this point that is marked on the graph, which is up 4, right 2, that when simplified will equal 2. They did show you in doing this, and we can zoom out to see this, they did mark an approximate point where the y-intercept was. And now that we actually plug this in, the Desmos graph confirms that this is the y-intercept at 0, 10. And it does pass through the point, and it does have the slope, so that does mean it's correct. So we're kind of using that just to kind of get some feedback that we were doing that correct. And then I'm going to move into some honors questions. So if you had some questions or are watching this for Math B Essentials, you might turn off the video now, although you're welcome to watch it. And we'll move through these questions. And all of these questions, for the most part, pertain to the 6-1F lesson. Okay. I'm going to go through these maybe in no specific order. I'm just going to start to cross off some of these. Let's look at this one right here, which says, will there ever be 2 different versions of the right answer that are both simplified? I can't think of a time when that's the case. And so I'm just going to cross these off as I go so I kind of remember that I answered these. So the answer is no. There is one best simplified answer. And if your answer is not the same as the one on the key, it means that maybe you didn't fully simplify it. And so you have to start to get in the habit of checking that the radicand, the thing in the square root, is fully simplified. So for example, this is a very easy example, but we'll look at it. 2 root 15 is 3 times 5, but you could probably start to check some of this in your head and know that although 15 is a big sort of looking number, that it is actually fully simplified, that 2 root 15 is done. So to answer that question, there shouldn't be two versions. Um, and let's look at some other ones. Is there a way to know that an equation or maybe an expression is fully simplified? And how do you know how that you chose the right square root? There isn't necessarily a right or wrong way. There might be a better way. Um, and how do you know it's fully simplified? By just double checking your radicand. And in a minute, when maybe I do some of these, I'll maybe kind of touch on these two questions again. Um, but unfortunately, there's no way to verify these. So now let's actually look at some of the problems that people kind of wanted some guidance on. And that might also kind of go back to those questions. So we'll start with numbers 21 and 22 came up. So 21 was simplify the square root of 0.8 repeating. So we can't, or it's not a good idea to deal with a square with a decimal inside. And so, and in fact, this was the question too about decimals. I'm going to always instantly change these into a fraction unless it just so happens to be like the square root of 0.04, where I can kind of just use my perfect squares and put the decimal point in the right spot and be done with it. This is not the case. And probably a lot of the ones in the homeworks now, you can't do that. So I'm going to erase this for now. I'm going to need to do this because this is not simplified, because a decimal and a square root essentially means there's a fraction and we have to get rid of the square roots in the denominator. Then I'm going to square root the top and bottom individually. And part of why I'm doing that is I kind of can see that if I do that, it rationalizes the denominator. And this is 2 times 4. 4 is a perfect square, so I have 2 root 2. And that is fully simplified. Or 2/3 root 2 is also the same. Or I guess if you really now wanted to write it as 0.6 repeating times root 2, you could. But after all that work, I'd probably keep it as a fraction. So that's 21. I also see 22. 22 was root 3/4 times root 7/8. Okay, so what are my options here? I could simplify each one on its own. I could multiply them together and try to simplify them. I don't know necessarily which way is better, and it's been a while since I've done this problem. I'm going to try doing each one on its own, and then maybe I'll multiply them together. Because I noticed that this one's going to be root 3 over 2, because the square root of 4 is 2. And then this one's going to be root 7 over the square root of 8. And notice how I didn't necessarily break this up into separate square roots, because after a while I don't always do that. And the square root of 8 is 2 root 2. Okay. And now I'm going to merge this together. I'm also maybe looking for things to cancel within the square roots, because I'm allowed to cancel as long as both parts, or they're both radicands, but nothing there. So I'm going to do root 21 over 2 times 2 is 4 root 2. And then when I rationalize, I'm only going to rationalize with the root 2. Because if I do the 4, if you tried that, you realize that that was more work than what you really want to do. 4 times square root of 2 times square root of 2 is 2. So root 42 over 8. And I can't simplify that. I can't cancel these. Let's see if that's what people got. Cool. And let's see. Yep, lots of people got that. Let's look at some of the other questions. So I answered 21 and 22. Somebody says they don't understand 23. That's the answer key. All right. I think they probably meant 22. Confused about how you answer questions like this with variables in the mix along with decimals. I did 21, so we can look at 18 and 20, and maybe also 11. So 18 is root 6a over root 3a. Or sorry, I read that wrong. 6a over root 3a, 18. And this one looks like it is stuck. So I'm going to rationalize. These just become a 3a, and then I'm going to simplify. And I know that this is a dead end in this radicand, but if I'm not convinced of that, I try to pull out pairs, and there are not any pairs there. And that's what most people got. Another one was 20. 2 over root 300. I'm going to start by simplifying this. 3 times 100, there's a 10 that comes out. That's stuck inside. And then I'm going to cancel these. And then I'm going to rationalize. 5 times 3, which is 15. I'm going kind of fast through these. The other videos I showed in the lesson hopefully went a little bit slower. I'm now kind of showing maybe the amount of work that I would normally do. But feel free to pause, rewind the video, retry some of these, or send me a comment in Google Classroom if you need some explanation on why root 3 times root 3 magically turns to just 3. All right, so that was 20. We have 18, we did that one, and we have 11. Let's go to slide 11 and see what questions people had on 11. 5 root 600 over, is it root 75? Cool. Okay, so first off, I notice I could simplify each one. It would be a horrible idea. I could start by rationalizing. Maybe the best idea might be that 75 is divisible by 25, and 600 is divisible by 25, and that's going to be 24. 5 root, the root hasn't gone away when I cancel these. 24 over root 3. Ooh, actually I can cancel more. This will be a 1, this will be an 8. 5 root 8 over, technically root 1 if you want to see that, which is just 1, which is just 5 root 8. And in a previous one, I did root 8, which was 2 root 2, which is 10 root 2. So if you notice you're getting a huge mess, and although this might look messy, it isn't a mess. If you get a huge mess and trying to simplify this, maybe you overlooked something like canceling here. That just makes this problem way easier if you notice that you have 2 square roots in a fraction. Maybe doing that at the start will make it much cleaner and easier. And that just comes with practice. Let's make sure we did this correct. So 10 root 2 and 10 root 2. Cool. So those were the questions that came in this week. Feel free to email me or send a private comment, and I can answer them next week. And I also have some office hours next week, so feel free to stop by.